In this video, I will go over the homework that follows the lecture 17.2 called Initial Value Problems, in which we will solve many initial value problems. And as always, I hope that you watched the lecture, and let's go ahead and take a look at the homework. And the first problem is giving us the differential equation. And how do we know that this is an initial value problem? That's because we are given an initial condition right over here. And this is a simple differential equation. And what makes it simple is the fact that y prime can be isolated. And when y prime can be isolated, the solution can be easily obtained by integrating both sides. And that's the idea. Now, to execute it, we are going to take our equation and rewrite it. So first we're going to isolate y prime. And after we isolated y prime, we're going to find the general solution by integrating this. And this is very simple. It's just two integrals of two simple functions. Again, I know I just did this earlier, but do not recall the integral of ln of x, so may possibly have to do integration by parts here. However, if you have a problem like this, feel free to just look it up in the table of integrals. So the first one is 4x squared, and to find the integral of ln of x, I'm going to be doing by parts. U is ln of x, dv is dx, du is 1 over x dx, v is x. So here we have minus uv, so x ln x, minus integral of v du, which is just integral of 1, which is x. Now remember it. And we have plus c. So this is the general solution. To find the particular solution of the given initial value problem, that is to find the solution that satisfies the initial value condition, we have to find the value of c that makes y of 1 to be equal to 7. That's the condition that we are given, and there's only one value of c that makes this true. So let's go ahead and compute it. We have 4 plus 1, so we have 5 plus c equals 7. So c equals 2. So the following function is what we would call the particular solution to the given initial value problem. And that's it. So let's go ahead and write this. Excellent. Determine if the function is a solution to the initial value problem. Okay, so let's write the problem. So I'm going to copy the differential equation right over here. And we have the initial condition, and the proposed solution is this. So this, in order to be the solution of this initial value problem, it has to satisfy the initial condition, so y of 0 must be equal to 0. cosine of 0 is 1, 1 minus 1 is 0, so 0 is equal to 0, so that's good. And it also has to satisfy the differential equation. So to check that, I'm going to find y prime, so y prime will be equal to negative sine 2x times 2, which can be rewritten like this. And now I'm going to plug in y and y prime into the original problem. So first I'm going to write the left hand side. So we have 4 sine 2x minus 3 cosine 2x plus 2. And now I'm going to write the right hand side here. I may need more space there. So on the right side we have negative 3y minus 2y prime, so minus 2y prime. And we also have minus 1. And now we have to check whether those are the same. And we see that it looks like the last coefficient is not the same. Everything is the same except on the left we have plus 2, on the right side we have negative 1. So it looks like it is not a solution. So the answer here is a no. Clearly made a mistake, forgot to distribute the negative 3 over here, right? So we end up with plus 3 minus 1, which is exactly 2. So technically it is a solution. Am I given a second chance here? That's unfortunate. But makes sense, because if it's not one, it's got to be the other one, and we don't want you to be guessing, but we don't want to make mistakes that I just made here either. So minus 3x cubed minus 12x squared minus 6x minus y prime plus 7 is the equation. The initial condition is that. So the proposed solution is that. And to check, we're first going to plug in 0. So at 0 it's equal to 4, which is correct. And next we're going to find the y prime, so it's going to be minus 9x squared minus 6x. And now I'm going to plug it into the original equation. So the left hand side will be y plus 3, so it's going to be negative 3x cubed minus 3x squared plus 4 plus 3, so this is my y. And we got y plus 3 on the left. On the right side we're going to have negative 3x cubed minus 12x squared minus 6x minus y prime, so negative 9x squared negative 6x plus 7. Now negative 3x cubed matches negative 3x cubed. Negative 3x squared matches negative 12x squared plus 9x squared. That's exactly negative 3x squared. Here we have plus 7, here we have plus 7. And this negative 6x plus this 6x becomes 0. So it looks like it checks off. So this is a solution. In this case, it's probably the solution because this initial value problem has only one solution. So we are asked to solve a initial value problem. Here's what it is. And to solve it, we're going to recognize that this is a simple equation, meaning its general solution can be obtained using this formula. So this is the idea. Now, to execute it, we're going to set it up according to the formula. we know that derivative of what function is equal to secant squared tangent, right? So using linear substitution here, we can conclude that this is negative tangent pi x plus c. But since this is an initial value problem, we have to make sure that y of 3, that is, when I plug in 3 into this solution, the output should be negative pi. And tangent of 3 pi, that's just 0. So here's your value of c that makes this solution to satisfy both the differential equation and the initial condition. So let's go ahead and enter this answer. Great job. Similar to what we've done before, we have an equation. A lengthy one. We have the initial condition. And the question here is whether this function is a solution to this initial value problem. And first we're going to evaluate it at 0. So we have cosine of 0 plus 5, that's 6. So that's correct. Now we're going to find the derivative. So it's going to be negative pi sine pi x. And now we're going to plug everything in to the original equation. So we have 2 minus 2y. So I'm going to try to squeeze everything in here. On the right side we have negative 2y prime. So negative negative becomes positive. And then we have all that stuff. So we have negative 2 pi sine of pi x. We have minus 2 cosine of pi x. And we have minus 8. So now this cancels. We have negative 2 cosine pi x. We have negative 2 cosine pi x. We also have here 2 minus 10, which is negative 8. And on the right side we also have negative 8. So it looks like it does satisfy it. So this is the solution of this initial value problem. Have another problem. This is the solution, actually, so this is the problem. This is the initial condition. So first thing we do, we plug in 0 to check if it works. And it is not equal to pi over 2. So this is not a solution because it doesn't satisfy the initial value condition. We have another problem. So this is my equation. is my condition. This is my proposed solution. And first thing I do, I plug in 0. And 3 times 0 is 0, e to the 0 is 1, so we get -2, which is -2, so that checks off. Now I have to find y prime. And now we're going to plug everything into the original equation. So this is my left-hand side. This is my right-hand side. And let's check. So this 3x will cancel this 3x. We have 3 here. We have minus -3 here. We have -3 e to the -3x. We have negative e to the 3x here because this negative gets distributed. So we have -1 minus the other 2. So we have -3. So it seems like they are equal. So this is a solution. So the proposed problem is, proposed solution is this. And it is indeed e squared over 16 times 4, which is that. So it does check off. Now we're going to find, I guess I went a little too fast here. So this is me trying to evaluate y at e over 4. And now I'm going to find the derivative. And plug it in. So we have, on the left-hand side, we have -2 times 2 over x minus e to the power 4x plus 1. On the right side, we have -x plus 2e to the power y, which is that. So here we have -4 over x minus e to the power 4x plus 1. It doesn't seem like it adds up, right? So it doesn't seem like they are equal, so this doesn't seem to be a solution. Oh, it says find the solution, so let me set it up differently. Just put the initial condition here on the right side. To find the solution, we're going to acknowledge that it's a simple differential equation that is y prime isolated on one side, and on the other side we have a function of x. So such equations are solved by integration of both sides, and therefore y would be equal to the integral of -4x plus 6e to the power 3x dx. So the answer is -2x squared plus 2e to the power 3x plus c. Now, this is the general solution. To find the particular solution, we have to make sure that y of 0, that is negative 2 times 0 squared plus 2 times e to the power 3 times 0 plus c is equal to 4. So that means 2 plus c equals to 4. That means c is 2. And that means y equals negative 2x squared plus 2e to the power 3x plus 2 is my particular solution. Looks like my pen is leaking here. So let's enter the answer. Minus 2x squared plus 2 times e to the power 3x plus 2. Excellent. So let's go to number 10. So this is, it looks like some sort of, I'm still going to copy the problem here. But it seems like it's an interactive exercise. But before we take advantage of it being interactive, let's find y. And let's use the initial condition. So this is the general solution. And if we're looking for particular solution, we found the value of c. So here's the particular solution. That's not what they are asking us to find here. Let's take a look at what they're asking us to find. So, drag the red point initially placed on the left side. Interesting. So, the only thing we know here, or we can just use the knowledge of initial condition here. Y of 0 is equal to negative 1. That's this one. I think they just want us to drag the line. So this is how we identify this solution. But in real life, like this is what our solution looks like. So it doesn't hurt for us to just graph it. Since the function was easy enough for us to solve it by hand, right? So this is what the graph looks like in real life. But in Desmos, we're just asked here to pick the right solution. And we picked the one that satisfies the initial condition. So I think that does the job. And let's move on to the next question. Hopefully the last one. We have initial value problem. And we're gonna solve it by integrating both sides. And here we have negative x to the power 4 plus 2x squared plus c. This is the general solution. And to find the particular solution, we're going to use the fact that y at 2 is equal to negative 4. So we got negative 16 plus 8 plus c equals to negative 4. Looks like c is equal to 4. So y being equal to negative x to the 4 plus 2x squared plus 4 is the particular solution that we were looking for. And it looks like we achieved 100% mastery. So if you have any questions, please reach out to me.